Good morning everyone. I hope everyone is fine. I just decided to just take a video of my working and hopefully it will be able to save time in the morning. So converting recurring decimals into fraction. So I have my example there, convert 0.14 into a fraction. So 1/4 is recurring. We have dots, okay, as you can see. So 1/4 is recurring. Let's go very fast. Step 1. What does step 1 say? You refer to the PowerPoint. It says make your number equal to x. And then to make it easier for you, write your number in expanded form. Expanded form means, it simply means you interpret what 0.14 means. What 0.14 recurring means. So 14, 14, 14, 14, 14, 14. That is recurring, yes? So you have that number. This is your number there now in expanded form. Then step 2, when you look at your PowerPoint, it says multiply your number by the powers of 10. We are referring to this number here. This is my number. Multiply your number by the powers of 10, such that when you multiply your number by the powers of 10, it means that you'll be moving your decimal point. Where you move your decimal point, the number after the decimal point should also be recurring. So let's take 10. We multiply our first number by the powers of 10. So 10 to power 1, we take 10. So 10 times x, we get 10x. Then if we multiply this number here by 10, it means we are moving the decimal point forward one time. So we'll have 1.41414. And this number after the decimal point is not recurring. So we move on to another power of 10. So we take 100. So 100 times x, we get 100x. Then 0.1414. If we multiply this by 10, we move 2 times. So we are moving the decimal point 2 times. So we move 1 and 2. So we have 14.1414. And as you can see, after the decimal point, our number is recurring. So this equation is okay. This equation is okay. So we go to the third step, which is actually subtraction. So we take the two equations that are okay, the first and the third. So we take 100x is equals to 14.14 minus the first equation, which is okay, because after the decimal point, 1414 is recurring, and then you have that. And then you subtract. Then another hint, when you subtract these numbers, you should be able to get zeros. So anytime you have such and you don't get zeros after the decimal point, then you know something somewhere is wrong. So that after the decimal point, I have zeros. So this is okay. Then you move on. 14 minus 0 is just 14. Then 100 minus x is 99x. Then, so you have 99x is equals to 14. So you solve for x. How do you solve for x? By dividing both sides by 99. So x is equals to 14 over 99. And even if you do this using your calc, you will find that your answer will be 0.14 recurring. Okay, good job. I hope you got that right. Then let's go to our second example here. We are converting 0.83 to a fraction, and 3 is the only number that is recurring. Then we go to step 1, make your number equal to x, and remember to write your number in expanded form. So in expanded form, you just write those numbers that are recurring. So 8 is not recurring. The only number that is recurring is 3. So we do the same way. We multiply by the powers of 10. If we multiply this by 10, we get 10x. If we multiply this by 10, we get 8.333. Then I know someone will be quick to say, okay, we are now stopping at 10x because after the decimal point, we have these numbers that are recurring here. But you will realize if you decide to stop at 10x, and then you have now only 2 equations, and then you take 10x, let me just write it. If you take 10x, is equals to 8.333, and then you subtract the first equation, x is equals to 0.8333. Can you see that after the decimal point, once you cancel out after the decimal point, you won't be able to get zeros after the decimal point because we have 3 and 8. Can you see? So this is not okay. You won't take the second equation and the first one. So you move on to try 100x and see. So 100x, where are we getting the 100x? So you do 100 times x, our first number, remember you get 100x. Then you multiply your number here also by 100. By multiplying by 100, it means we are moving 2 times. So 1, 2. So we have 83.33. So that's okay. We can prove that. So let us now subtract the third step. So we take the third equation and the first equation. So we have 100x is equals to 83.33. And then if we take our second equation, we subtract the second equation, we have 10x is equals to 8.333. Can you see? You get zeros. But when you take the second and the first equation, you won't be able to get zeros here. So that's why we have taken the third and the second equation. So the third and the second equations in this case matters. But in the first example, we took the third and the first one, but here we are taking the third and the first. Remember, class, if you take the third and the first one, you won't be able to get zeros after the decimal point. And I have that example here. If I take the third equation, 100x is equals to 83.33, and I have x is equals to 0.83. Can you see I'm also not able to get zeros after the decimal point? So after the decimal point, I should be able to get 0, but I cannot be able to get zeros in this case. So this is not okay. If I subtract the third and the first equation, I'm still not getting zeros after the decimal point. But if I take my third and the second equation, I'm getting zeros after the decimal point. So in this question here, we are taking the third and the second equation. So then we get here, we subtract 0, 0 this side, then 83 minus 8, you get 75, 100x minus 10x, we get 90, then we solve for x. We divide both sides by 90. Let's do the third one now very fast. I want this video to take only 10 minutes. So step 1, so 0.147 recurring. So 147 is recurring. So step 1, you write that in expanded form. So you have 0.147, 147. You can even have another 147, 147. Then step 2, you multiply your number by the powers of 10. So 10 times x, you get 10x. Then when you multiply by 10, you're moving 1 time. So 1, so you get 1.47. So this is not okay because after the decimal point, 47, this is not true. We want a situation such that after the decimal point, we will have 147, 147. So we move on. 100x, we multiply. How did we get 100x? We multiply x by 100, so we get 100x. Then this other one also, we multiply by 100. We are moving 2 times, so 1, 2. As you can see, we get 14.714. Can you see after the decimal point, these numbers, they're not recurring. They're not the same as what we are having as our question. So that still is not true. We move on to 1,000. So we take 1,000 times x, we get 1,000x. Then 1,000 times this number, we are moving 3 times. So we move 1, 2, 3. And after the decimal point, we have 147, which is recurring. So we take that equation is okay. Higher, then we take 1000x is equals to 147.147. Then we subtract the first equation, which is x. X is equals to 0.147. Can you see when we carry out subtraction, after the decimal point we have zeros? So that's okay. So 1000x minus x, we get 999x is equals to, when you do this, you get 147. So you divide both sides by 999 just for you to get the value of x, and you can always simplify that. I hope you got the concept, and just in case you have not understood, I'm there to help. Then you can try out the worksheet, questions in the worksheet on recurring decimals.